Hi, this is Steve Yee, Director of Product Management for SQL Azure. In this walkthrough, we'll discuss the value of using SQL Azure Data Sync to provide bidirectional synchronization and data management capabilities with on-premises and cloud databases. First, we'll cover the benefits of using SQL Azure and explain how businesses can use SQL Azure Data Sync to share information efficiently. Then, we'll highlight some Data Sync use cases and outline the features of SQL Azure Data Sync. Next, we'll demonstrate how to establish synchronization between an on-premises database and SQL Azure, as well as between two SQL Azure databases. We'll also show the sync results in real time within a web application. And finally, we'll point you to some additional resources to help get you started. When you move your data to SQL Azure, you can free up time and reduce risk associated with managing and maintaining your own in-house database servers. Once in SQL Azure, your database is highly available, reliable, and scalable, and can be accessed from anywhere via the Internet. SQL Azure is also highly flexible and allows you to pay as you grow, eliminating the need for upfront capital expenditures. Now, let's look at the features and business value of using SQL Azure Data Sync. Currently in Community Technology Preview, or CTP, SQL Azure Data Sync enables enterprises to easily and quickly share data between both on-premises and cloud databases. The hub-and-spoke model of SQL Azure Data Sync can address complex business needs by allowing for bidirectional flow of data. Bidirectional flow creates symmetry between on-premises and SQL Azure databases as changes to either location are automatically synced. In addition, businesses can easily expand their reach since georeplication allows data to be shared across multiple global data centers for redundancy and also to reduce network latency by placing the data closer to end users. Using the SQL Azure Cloud Database makes it far easier to store and distribute large amounts of data globally. SQL Azure Data Sync provides numerous features to efficiently duplicate, send, and share data across your business or web application. Setting up SQL Azure Data Sync requires no coding. The service does most of the work for you, making it easy to establish synchronization, which gives you the flexibility to deploy applications and databases without worrying how to tie them all together. Establishing synchronization can be done in minutes with few requirements. With a predefined sync schedule, you can define when and how often your databases synchronize. Once scheduled, your SQL Azure database will automatically sync based on your specified need, whether that occurs daily or in real time. Either way, it's easy to schedule and modify and requires no coding. SQL Azure Data Sync also makes it easy to set rules to automatically handle any potential data conflicts. You can now establish and modify the rules that govern how your data is handled in order to keep your data flowing. Finally, unique logging and monitoring in SQL Azure provides visibility into your system via a central dashboard that helps you monitor your system's health and understand how your data synchronization is working. Let's begin the walkthrough and try out some of the sync capabilities. We're going to synchronize an on-premises SQL Server database, a SQL Azure database, and also sync a second SQL Azure database which will be used as our hub. This scenario is most relevant to situations where the cloud is being used as an extension of the on-premises database to provide scalability. In this scenario, we have an on-premises access application that serves as the user interface and accesses the SQL Server via linked tables. We will show how to sync this data with the SQL Azure database we've already created. If you don't yet have a SQL Azure account, visit www.sqlazure.com for more information on how to sign up. Once logged into the Data Sync dashboard, we'll need to download the agent in order to initiate the sync. The agent links the SQL Server database to the sync service, and the first time that we start a sync, the agent publishes the database schema for the on-premises database to SQL Azure. I will select the Agents tab and scroll down to the bottom of the screen where we can download and install the Agent Service Setup MSI. Click Run to start the download, then click Next and read through the license agreement. Select I accept, and we will enter our local credentials to run this Windows service. After I enter my credentials, I'll click Next. Let's choose a location to save the file and specify who will be able to use the agent from my machine. Then click Next. And click Next again. Click Close and the installation is finished. Now, we will set up the agent in order to add our local SQL Server database to the sync service. From the Start menu, go to the SQL Azure DataSync folder to run the SQL Azure DataSync Agent Client tool we just installed. If we ping the service, we see that the agent access key has not been specified. Back in the DataSync dashboard, navigate to the Agents tab where we can finish the on-premises setup. Click on the Generate Agent Key button and enter a name for the agent. Now click Generate. To display the agent key and finish setup, click on the agent you just created. Copy the key that is displayed and move back to the agent dashboard. Once in the agent dashboard, click Edit Agent Key, paste the agent key into the blank field and click OK. We will test the key by pinging the service. Now it works. Back in the main DataSync dashboard, we see that our on-premises database is not yet visible. To make the service available on our machine, we will need to run certain administrative features. By going to the Start menu and select Administrative Tools, select Services and find SQL Azure DataSync Agent. As you can see, the service has not yet started, so click the Start button to run the service. With the service running on our computer, we can now add our local server to the sync, so we will select Add a Member. Enter the server name and the database we want to sync. Now click Save. And with that, our on-premises database is ready to be synced. Okay, the DataSync dashboard now displays our local database. We can now add our SQL Azure databases as well. Click the Add button. Enter the server name and database name, as well as the associated username and password. Click the Test button to make sure it works. The connection was successful, so let's go ahead and click Save. Now we will add our third database to be synced using the same steps, so click Add. We will be adding a second SQL Azure database to the sync group, so I will enter the credentials and click Save. Now we can see that all three databases are listed in the database management queue, so the next step will be to establish a sync group. Click on the New Sync Group button and enter a name for the sync group. Next, use the drop-down menu to select our on-premises and SQL Azure databases and add them to the sync group. We can decide which database will be used as the hub. I will use one of our cloud databases, as this will be the master database from which the others will sync to. Highlight the desired database and click Set Hub. Now our hub and spoke sync model is established. With all of our databases added, click the Next button. Now let's decide which tables in our on-premises database we're going to sync with our SQL Azure databases. Highlight the desired tables from the local SQL Server database and click the arrow to select them. You can establish a schedule for how often your databases will sync, ranging from every 5 minutes to every 23 hours. Once you establish the desired schedule, click Create Sync Group. Select the sync group we just created and click Sync Now. Next, we are taken to the sync log page where we can see the status and execution of our sync. The log shows that we have finished all of our tasks. Now that the sync has been created, we will go back to our on-premises Access application where we can see our expense report details. This data is linked to our on-premises SQL Server database. If we make a change in our on-premises database, the sync service will automatically write the changes to the SQL Azure database in our sync group. We'll see the changes reflected in a web application that reads data from our cloud database. To observe an automatic change in the entry, we'll switch back to the DataSync portal and click Sync Now. Navigate to the Sync Logs tab and refresh the tasks. Because we have synced the on-premises database with our Azure database, we should see the new entry in our cloud-based application. Let's now navigate to our web application, which displays the same expense data but is pointing to our SQL Azure database. When we refresh our browser, we can see that the data field in our web application reflects the changes we just made. Sure enough, our sync group has been set up correctly and our on-premises data is accurately synced to our cloud SQL Azure database. In this session, we discussed the benefits of using SQL Azure, including the important features of SQL Azure DataSync. We talked about specific usage scenarios and highlighted the features of the DataSync service. We also showed you how to sync your data in a few easy steps and view the changes in a web application pointing to SQL Azure. Thanks for watching, and please visit SQLazure.com for the latest information and additional resources.